Okay, so I'm going to try to cover these things, so like the different models for like digital identity online, different approaches, why I think it's not very good at the moment. So then look at some credentials in a physical world, and then try to go into self-sovereign identity in detail. It's not going to be too much on the cryptography, but if you are interested, I can definitely send you some papers. It's a bit of a rabbit hole, but yeah, okay, so I think there's three main models. This first one is like siloed identity, federated, and then like this new one, which kind of isn't around yet, but hopefully will be soon, like self-sovereign. Yeah, so the first is siloed identity, and this you only exists inside that entity. So you don't really exist outside of it. And the problem with that is you end up having loads of these different identities inside different organizations, and they're siloed, so you can't go across, you can't transfer any reputation, you have to create a new password, you're trusting that entity to look after your information, and you have to do it over and over again. So yeah, it's a lot of passwords, not very good for usability, because obviously everyone just puts the same password in. If you get compromised in one place, potentially you're going to get compromised in a lot of places. You can't move around, so I think that's a big thing. If you wanted to quit an organization or like a website where you built up a lot of kind of trust, reputation, anything, if you want to leave there, nowadays you leave all that behind. There's no way to bring anything with you. It's okay. Yeah, so the second one is federated identity, and I think this is the one we kind of use mostly today. This is like your Facebooks, your Googles. You know, they federate your identity across all these different websites, and that's great because it means you only need one password, your Facebook password, and then you can log into all these different places. But I think the problem with that is the identity provider becomes this big entity, and they can see all of your interactions digitally. They sit in the middle of them, and they can learn from them and potentially use that information to benefit them without your control. These guys are in control. You still don't really exist as your own entity on the internet. Yeah, so I think this is bad for privacy. Obviously, these identity providers, they are in control. They can see everything. They have the bigger picture than you, really. I think it's bad for security, as we've seen recently. Like if Facebook gets compromised, that means all of these. So they provide you with a token. If that gets compromised, then they can log into all of the sites that you've used Facebook to log in with. But it is an improvement. You only need a couple of passwords. Yeah.
Well, I thought I read something debating between using like Joe Schmo's site or using Facebook to log in, and the argument was that Joe Schmo's security on the passwords are going to be a lot worse than Facebook's. So that was the argument for why it's more secure. But you're saying, what does it mean to lose a token as opposed to lose like an actual hash password?
So I think it's similar. So the problem with Joe Schmo's site is if I put my password in that I use all across the place and that gets compromised, then we can use that password to get into all these different places. But with Facebook recently, there was this thing, their Open Connect. So every time you log in with Facebook, it passes a token to this website, I'm pretty sure, and that uses it to authenticate. So if some hacker can get access to this token, then they can use that token to log into all of your websites where you've used this kind of token that Facebook provides. So it's kind of the same thing. They've got some piece of information they can use. And whereas in Joe Schmo's site, where if you are being secure, you should use a different password in all your websites. So ideally, they only get access to this one site. It's different. It should be more secure, but if it is compromised, then it's less secure. Yeah, then finally there's this new model, self-sovereign identity, and I think the idea here is that we all exist on the internet as a peer, and I can interact with an organization, an individual, and we all interact in the same way. It's kind of two-way authentication. I get to look after my side, and the other person gets to look after their side, and we can both prove who we are to each other. Because now, when you're logging into a site, you're trusting that that site is who they say they are, but you have no real way. You know, they're checking your credentials, but you don't really check their credentials. Yeah. So yeah, it's peer-to-peer. There's no need for this third party. I can connect with anybody. As long as we can trade this information, we have our own private channel. There's no Facebook in the middle of that. Nobody can see. Yeah, we use cryptography to authenticate ourselves, and we can share these credentials, which can be verified using cryptography. Yeah, so that's kind of, if anyone's got any questions, just stop me anytime. It's kind of less the basics. So yeah, I think this is like this is like an old advert in the New York magazine or something, and it's on the internet. Nobody knows you're a dog because there's no real way for you to prove who you are. It's kind of been broken, and it's still broken now. It's quite, I guess if you ever go to identity things, they always chuck this one up. Yeah, so I think the problem is the security of our information. Like, that's just an infograph of the amount of personal data that's been hacked. So Marriott Hotel, 500 million. I'm not sure how out of date that is because there's probably some new ones that I'm missing, but the problem is we can't trust these organizations to look after our personal information. Yeah, and the next one is privacy. Like, you are being correlated, your information is being correlated across all these different data sets you have online by a few large organizations. And I think it gives them unprecedented insight, and this insight is unequal. Like, you don't have that insight into what they do, but they still know it. Pretty much everything you do online, there is some organization that has that big picture. Yeah, so like these organizations, right, they have gained huge amount of power by being the brokers of our digital interactions. You know, they sit in the middle of all this stuff and they extract information and they use that to sell to you. Like, it's been called like surveillance capitalism now. The new way of selling predictions about what you will want in the future so they can advertise and in a way direct you to that. Yeah, and then this one's big. The current approach to identity, I don't think, and a lot of experts say, it's not going to scale. There's no way we can keep doing this model where we have a few identity providers providing internet to all these people who need an identity. Like in Africa, if you don't have an identity, I don't think we appreciate that here, but you know, if you can't prove who you are, then you're just off the grid. There's no way you can get access to help that you need. I think it's a real struggle, and that's kind of what I'm most interested about this, is hopefully we can give these people an identity that they can use that won't be corrupted by the organizations or countries that they're from, and then they can start to prove things about themselves and build up this reputation. Okay, cool. Yeah, so let's look at, in the physical world, I think this is different, right? When I go to a shop, I don't give them my credit card and they keep that in a file, and then when I go back I say, oh, this is my name, they get out my credit card and use it for me, do they? I use my credit card, I pay for something, I put it back in my wallet. It's like, these are the credentials, right? We have them, we all have them, they're physical, they're controlled by us, so they're not owned by us, right? The passport is the property of the British government, but I still get to control who I show it to, when I show it, and then people I show it to can verify that this is indeed a passport from the British government, but they don't need to keep hold of it, and they don't need to create a record, really. They just check, and that's enough for them, that you have this credential. It's like, yes, this person is allowed to do this action, like board a plane. Yeah. So I think the key thing here is these are, we control our physical credentials, but we do not own them. Yeah, so and this is just another example. If I go into a bar, I show the person my license. Maybe they verify it, maybe they put it under that light, check that it's real, and they go, yeah, that's okay, you're over 18, you've got a valid credential that says that, here you go. And I put it back in my wallet, and I walk on. It's very rarely are they going to write down any information. They really shouldn't be doing that. And I think an interesting thing here, which I'll go into later when we look at these in the digital world, is even though I'm doing that and I'm giving them my driving license, I'm still giving away a lot more information about myself than I really need to. Like, all that bouncer needs to know is, yes, I'm over 18, or no, I'm not. But when I give them my driving license to get my address, my date of birth, my full name. I think that's one of the reasons that digital credentials can be a lot more powerful, because we can really start to decide exactly how much information that I need to give away and only give that. Yeah, so the idea really about self-sovereign identity, this new way of doing identity, is how can we replicate the physical world, those interactions, in a digital way? You know, how can I start to build up these credentials that sit in my physical wallet that I then use to prove things about myself digitally, but without this need for me to create an account? Like, really, they're just checking some attributes about me, and if those attributes match up, then I should be allowed to do some action. Okay, let's have a look at this, how this kind of works in more detail. So yeah, there's kind of a workflow for this is me, I have my self-sovereign identity. I'll make a connection with an organization. You know, that's the peer-to-peer connection, an individual. Then they'll probably request a credential from me, like, are you over 18, or, you know, are you eligible to do something? And so that's actually presentation. I did that a bit wrong. Or then these people are going to issue me credentials. So like maybe the government's going to issue me my passport, but in a digital way. So once we have this connection, we have this peer-to-peer private channel, we can start to communicate and start to share credentials. Either I'll present some things about myself, or they're going to present some things to me, which I can then hold in my wallet. And then the final thing is, when I am presenting a credential, the organization that I'm presenting it to across this private channel gets to verify this credential is correct. Yeah, so the requirements for this is both parties share this thing called a pseudonymous identifier. So that's completely different to how we do it online at the moment. Mostly, if I have an identifier, it's a unique identifier that is used everywhere. So like if you have a look in government like services, they'll have one identifier for you that's used in all their databases. And that seems okay, it makes it easy, but the problem is if one of those data sets gets compromised and they get access to your identifier, they can start correlating you across all those different data sets. We really want to move away from that. Like this, I should be able to be this identifier to you, but a completely different one to somebody else. And there should be no way for us to link those identifiers. The only linking of information is when I decide to share a credential with one person and I share it with another. You know, I decide to share 2 bits of information to 2 different people, so they both know that information, but they still don't know that I'm these different identifiers. I want to make it as hard as possible to correlate you online. Yeah, and so then these identifiers, you've got to be able to prove. Oh.
So, would you say that is like having your public SSH key?
Yeah, it's kind of similar to that. So there was PG, pretty good privacy, or yeah, and that was kind of similar. It's like where we share public keys, but I think the problem which SSI kind of solves is how do we start sharing these keys in a way that I can trust, right? If I meet you, then we can share keys and it works okay, right? But what about online? Like, how does that work? I don't know if I've actually gone into that, but the idea currently online is you go to a website, they'd maybe have a QR code. You could scan that QR code, and that's their public identifier. So that is used all over the place to identify this organization. Through that public identifier, I can communicate with it on the public endpoint and say, here, this is me, here's my new pseudonymous identifier. And they'd go, great, and they'd send me back an identifier which is just for them for this interaction. So we now have 2 identifiers that are unique, and they can form this connection through which we can start communicating across and authenticating. So like I'll be able to say, this is my identifier, here's the cryptography, the signature that proves this is me. And they do the same, and then I know, oh, well, I must be talking to the right person. They've given me the right identifier, and they've proved that they control it. Yeah, and then this last point is kind of about that. Through these identifiers, which we'll go on to, we can build this authenticated communication. So I'll show you. Yeah, and so to solve this problem, there's this concept of DIDs, decentralized identifiers. They're kind of Under development are the W3C, so like the World Wide Web. Hopefully they're going to be like a formalized standard soon. And it's all about, we have these identifiers, how do we resolve the identifier so we can get the cryptographic information that I need to check someone actually owns this. So yeah, we have these identifiers and they resolve to a document basically. So that document contains public keys, it contains an endpoint, so like could be a REST endpoint, anywhere for me to just hit and communicate with this person and say, hi, this is me, here's proof it's me. And then I would also share in my identifier a way for them to communicate to me. Yeah. So this is kind of it. We have like the DID and then the method, so that kind of defines how does this identifier get resolved to a document. And then that is how I identify the thing. And you can see here, this is what it resolves to. This is the DID document. So you've got the public keys, the authentication type, and then the service, which is just literally any way to communicate. It doesn't have to be HTTPS. Yeah, and I think this is why DIDs are important, really. This quote, for the first time in history, an identity owner is no longer dependent on an external provider to gain the power of a permanent, unique identifier that can be looked up on the internet. Because if you think about it, what do you use as your identifiers online at the moment? It's an email address, right? And you don't really own that email address. If the email provider shuts down, you've lost your identifier that you use all over the place. But the idea with DIDs is nobody can take them away from you. Once you have them and you can control them and prove that they're yours, you should always be able to do that unless you decide you don't want to anymore. So I think it's really interesting idea, and the fact that we didn't have them before is quite shocking. Yeah, and so the key thing about making this connection is that we create this secure channel, right? So we can do authenticated encryption. I will use public key cryptography to share a key for like AES. And then we'll start communicating using AES. All our communication will be encrypted, and I'll be able to check, yes, this is the message that person sent, and I think that's quite important, really, because we don't want this information. Once we've got this secure connection, getting that might be a little bit hard, but once we've got it, I can be 100% certain that the information that I'm receiving is correct. Okay, then the next step is like issuing credentials. Once we have this connection, I can ask this organization, please issue me my passport. And obviously there may be some sort of communication about how that happens. I might have to prove some things, or maybe I go in person to the passport office, they check my passport and issue it in person. But the point is they'll issue me this digital credential. Yeah, and a credential it's kind of like a token, but it's a set of signed attributes. So like my name would be signed, my date of birth would be signed, and each one of these attributes can be presented independently. As long as I can, I'll show when I go to presentation how that works, but the point is each of these attributes are signed. The signed credential is under the control of the holder, just like a physical passport is. The issuer can revoke this credential. It's because I'm controlling it, but I don't own it. So if I do something wrong, so like I lose my driving license, that gets revoked, right? So there has to be some way, I'll go into this later, for organizations to revoke their credentials. And importantly, they have to be able to revoke their credentials in a way that a verifier can check this credential has been revoked without talking to the issuer. Yeah, so credential issuance is interactive, so we have to both be online, the organization is issuing and the holder, because we communicate together to create this credential, and the holder contributes some information to that credential which they can then use to prove that it's actually their credential. So yeah, this is kind of the interactive part. The issuer sends a credential schema, a definition of what this credential is going to contain, to the holder. The holder checks it, populates it with the fields that they want to be, that are them. Potentially this population would be through a presentation of another credential. And obviously, potentially, the issuer would be populating some of this information as well. The key part here is the holder makes a commitment to this secret number. Every person, every identity has a secret number. It's called a master secret, or it can be called other things, but just think of a big long number that only I have and only I know. Then I create a commitment, so basically like a hash or some way for me to hide this secret information in this credential. Because then later down the line, I can go, here's my credential, yes, it's mine, because I have this piece of secret information that matches this commitment. Yeah, then issuer signs a credential, so it signs all of these different attributes. Just like this. It'll sign the master secret, which is blinded. It doesn't know what the value of the master secret is, but it can still sign it. Signs every single attribute is individually signed. Yeah, so when you've been through this stage, I now have, or the holder now has, this cryptographic piece of information that they can store in their wallet. They can then use to show to people as they want. People might request it, and I don't have to show it. I can refuse, but if I want to, I can show it. And the point is, I can show this credential without the issuer of the credential ever knowing. Right? They've issued it to me. It's now under my control. I can do with it what I want. And there should be no way to trace that. Yeah, and the point of doing this signature, I didn't kind of touch on that. Once we have a signed piece of information, if that information changes, I don't think we've done digital signatures yet in the class, but the point is, if I change any piece of information, then the signature doesn't validate, right? So if I'm presenting a credential with a signature, but I've actually improved my test score, this credential, then they'll just say, no, these signatures don't match up. And we'll go into why this is just integrity, because there is a couple more things we need, but we'll go into that later. Okay, so the next step is I have a credential in my wallet, or a set of credentials, and I want to fulfill some need of an organization, so I need to log in, or I need to get special access, I need to do something, and that requires me to present some attributes. And the key thing here is I can make a presentation of any subset of the attributes contained in multiple credentials. It doesn't have to be just one credential. I don't have to present all of the credential. I literally get to choose which attributes I want to present or I need to present, and present only them. Yeah, so every time I present as well, we create a new signature. It's randomized, so we can't track. Basically, because if I was just presenting you this credential every time, the signature is going to be the same, and they're just going to say, oh, this is the same person presenting this credential. It's another way to correlate you. Yeah, and presentation is non-interactive. I can just send you a credential and a presentation, and you should be able to verify it without talking to me. Okay, so I don't know how that's going to look up, but the point is, I have these two credentials, my post office credential and the DVLA. They both contain this master secret, and this master secret has to be the same for me to be able to create a presentation from both of these. Because it's basically like saying, yeah, these are both my credentials. I can't use someone else's credential. So yeah, we have the issuer, the ID. So that's the identifier of the issuer, and that can be used to validate that these credentials are correct. And we have the signature, which is that signature we just created, signing every single one of these attributes. So I can kind of bring these together, pick some attributes from them, and create a new signature that is valid in one presentation. I'm a bit shaky on this. I don't know whether both issuer DIDs are included. I think so. But the point is we create this new signature that can be verified, containing information from both credentials. And the other thing we have is this signature of knowledge. So that is me creating a signature that proves that I do indeed have the knowledge of this blinded master secret. That's kind of how you prove these credentials are yours. Otherwise, you could just present any credential. And it's also quite nice because even though I'm presenting this presentation, nobody else could then represent that presentation to somebody else, pretending to be you, because they don't have this secret piece of information. Oh, actually, there was a couple other things. Yeah, so on here, you can also do zero-knowledge proofs. So, I mean, I'm kind of doing a zero-knowledge proof with this signature of knowledge, but you can also prove that I am over 18. So this would just be a proof that would evaluate to yes or no. And if it's yes, then the verifier knows with 100% certainty, give or take, that this person has an attribute attesting to the fact that they are over 18. It doesn't matter, we don't need to know what age they are. This just goes into the proof and it can be verified. Yeah, and the same with set proof. A set proof is different. Obviously, it's not a range. It's like saying these are different attributes. Do you fit in that set? But it's similar cryptography. And all that helps you to sort of fulfill this kind of need. We want to reduce the amount of data we are revealing about ourselves in our digital interactions, so that I only reveal exactly what is necessary for you to verify me or authenticate me to do some actions and nothing else. Okay, the next step is these credentials. When I present this credential to the verifier, they need to check the cryptography. They need to check all these proofs that I've created. So does this over 18 proof evaluate to true? Do you indeed have a signature of knowledge that you have the master secret for this credential? Does the signature created validate against the public keys of the issuers? So it's just a load of maths will go on, and eventually they'll add them all together, and it'll be, yes, this is a valid credential. So yeah, there's a couple of things that I haven't really touched on. I don't know if anyone wants to give any ideas of what that might be. You don't have to.
How do you deal with like the cryptography behind it, which will just decay over time? That integrity.
That's a good question. You mean is the cryptography when the cryptography gets cracked?
Yeah, because computers get faster.
Yeah, no, it's a good question. So that's why we use these things called DIDs, because I can have a DID, which is an identifier which points to a document. I can then update that document with new cryptographic keys that still will verify that, that same identifier. So that's why DIDs are quite powerful, because they allow you to do key rotation pretty nicely.
Yeah, I guess that's two things. First is who would be the issuer in this sense, and thinking like of an organization, and second, what is the financial incentive for OAuth organizations like Google and Facebook to decide I don't actually want to collect any data, despite that being their entire business model and making billions off of it.
So I'll deal with that one first. I think the idea would be that people would gradually move towards this system where they want to collect their own credentials, and Facebook and Google wouldn't have a choice but to follow, because once we start building up this ecosystem, so maybe just in a small ecosystem, the banks start issuing you some credentials. That's okay, it works, I can log into my bank using my own credentials, but it gets more powerful when people start building on top of these. They go, right, now I'm going to create an application that accepts credentials from the bank because I know I can trust these people, and we can start building up a much bigger ecosystem based on verifying pieces of information. So I think hopefully it would just sort of be network effect will just take over.
So this is another question. Is this the argument then it would prevent breaches, like breaches of information, like the Marriott hack wouldn't happen?
Yeah, so I think, so if I'm still presenting information about myself, that information potentially can still be stored on the verifier's servers, but there would be less of it, there'd be less information, and potentially I don't need to give my name, right? So they'd have this pseudonymous identifier and some information. But if all I've done is meet the minimum criteria for that website, then hopefully there isn't that much information there, and I can never be correlated because they don't have this identifier somewhere else to look up. So it gets much harder, even with compromised information, to start building up a bigger picture of who this person is, where they interact, and what they kind of... Yeah, I think people will get a lot more careful with revealing personal information about themselves using this, because a lot of the times you don't need my name when I want to log in. I just need to prove to you, maybe I just need to prove that yes, I'm living in the UK, yes, I'm a UK citizen. You still don't need my name. Well, very rarely you're going to need my real name for anything, right? And then the other point you said is the issuers. And I think this is the biggest problem with this system, right? How do we trust the issuers? Because this all works, right? We have integrity. These credentials, they are correct, but somebody could sign a credential saying that the sky is green, and that's a perfectly valid credential. It's all going to sign and it's all going to verify, but if you can't trust the issuer, then you can't trust the information that's been verified, even if it's correct. So yeah, so one is like DID resolution. I didn't touch that because I want to do it later, because that's kind of the blockchain distributed ledger bit, and I just want to make it clear that really that's tiny. That bit is small, and this whole cryptography behind this has been around way before blockchain or anything like that. Blockchain just adds a nice feature, which is that we can resolve these identifiers into their cryptographic information in a way that's decentralized and is highly available. So this distributed ledger, I can ask it for, I can send it, oh, here's this DID, return me the DID document, and should always return me the correct information, should always be live. And nobody is in sole control of that, so nobody can really take that away from you. Yeah, then the other thing is, how do we do credential revocation? It's going to be really important if I'm issuing these cryptographically verifiable pieces of information. If I make a mistake or if there's a need for me to take that away, I should be able to do that. Yeah, and then this is exactly that one about the issuers. Just because we have integrity of the information does not mean that we can trust that information to be correct. Yeah, so like this basically it. We have some problems right now. We can start thinking about what the solutions are, and it turns out the distributed ledger is quite useful. So yeah, I kind of touched on that already. Resolution happens. I send in a public. It happens different for every ledger. Anybody can implement a method, as long as it can take this identifier and return the document. That process can happen any way that you want. So like when it went DID sov, that was saying, right, use the sovereign method specification to resolve this ledger. But it could be Bitcoin or, do you know what I mean? Any, as long as someone's implemented a method to get from this identifier to this document containing this information, that's fine. Yeah, so I think I've touched on all that really. Okay, credential revocation. So this is a little more complicated, but basically there is this concept of a cryptographic accumulator. So every credential that's issued will get hashed and put into this accumulator, which is just basically a big hash of all the credentials. It's a big long string stored on the ledger. So it's highly available, anyone can access it. And when I'm creating a credential presentation, as part of that, I use this thing on the ledger to create a proof that my credential is indeed in this list of hashed credentials. And if the organization then wants to revoke my credential, they simply remove this hash of the credential, which they know, from this register on the ledger. And the point is then, when I send this proof to the verifier, they can check the proof against the ledger. They don't need to talk to the issuer. They just check this thing on the ledger, which is highly available and under nobody's control. And there's no way to check, right? It's not like the issuer is getting a ping every time someone wants to verify a credential is all right, because that would be bad for privacy. Yeah, and then this is the final one. I don't think a distributed ledger really solves the trust problem. Maybe makes it easier because this is an immutable ledger that nobody controls, but there's still all that this distributed ledger is used for, right, is holding some identifiers. It's saying, yes, this identifier is indeed on the ledger and here is its public keys. But if you don't know who is behind that identifier, then it's really hard to kind of trust it, right? I'm trusting this piece of information that someone's presenting to me by this identifier. There needs to be some way, a bit late. needs to be some way for me to, check. The simple way is within this ecosystem, I have a list of all the people that I trust to issue these pieces of information. These credentials. There's a list of credentials. These people can issue them, but that's really not scalable. So I think one of my kind of research goals is going to be to look at how we can have a more robust mechanism for trusting the issuers, right? We need some way that I can, in my application, someone presents me some information, I need to be able to give it a trust score. So at least some way that I can say, yes, this looks like it's probably true, or no, this looks a bit dodgy. Can you present me some more information to back that up, or something like that. But yeah, I just want to distributed ledger, not just because it's a distributed ledger doesn't mean we have trust. Yeah, so that's kind of it. Trust is crucial. Usually the verifier is going to need an existing trust relationship with the issuer. So like within an ecosystem, I know this issuer, I know this DID is the issuer because we kind of have an existing relationship. Yeah. But I think it's going to be interesting when we want to start building up these cross-ecosystem sort of, I want to trust something from this health sector. How do I know these people who the health sector issuers are? How do I get that information in a reliable way? Well, it's not under anyone's control, ideally. Okay, and then this is kind of like a review, nearly at the end. So the full workflow is, a credential issuer issues a credential. They define the credential, they sign the credential, and they can revoke the credential all using this distributed ledger. I then put this credential in my wallet. I can check the revocation registry to create these proofs that, yes, my credential is not revoked. And then I can present a proof to a verifier who identifies the issuer using the distributed ledger, verifies the signature, verifies all the other proofs, and then goes, yes or no. This is acceptable. No, it's not. So yeah, I think these have the potential to be better than physical credentials, right? I can now present you with some token. As long as you can trust this issuer, then you should be able to trust it 100% because it's trusted by maths, not just by you looking at some piece of paper and checking if you think it's valid, right? It's maths. You can't really fake that. Yeah, and I think it's another big one is like trust at a distance. How do I send my credentials to America? Say I want to apply for a university degree in America. How do I do that at the moment? I'd take a picture or something. It's not very good, whereas I could send this digital token, just send it across some encrypted channel. They'd be able to check it, verify it, and if it all matches up, they know with 100% certainty, even though they've never met me, that I have these pieces of information. Yeah, and then finally, it's like that thing about subset of information. I don't have to give you my whole driving license anymore. I can just tell you that I'm over 18. Yeah, and then there's some principles. I put a few links on these slides if anybody's interested. This one is a really good introduction to kind of the ideas behind self-sovereign identity. So, I'll just let you read them mostly. I think an important one is existence, right? These, just because you aren't able to, it should be physical first, right? Everybody exists, and it shouldn't be based on their digital presence that they exist. It has to start with the physical. Yeah. So I don't know if anyone has any questions. I think I'm pretty much done. Yeah, so I hope you can see that this way has the potential to be a lot better. We can start having really trusted pieces of information online. And it's really going to empower the individual, not these big organizations, to be in control or at least be on the same level as organizations online, right? You can start building up your own presence and start being able to prove things about yourself. Yeah, and I reckon this could take like 5 years maybe before we start seeing some real applications that are actually useful. There's a lot of POCs going on. There's a lot of work going into this. It is an exciting field, I have to say. But this takes time, right? I think the cryptography is there, the underlying technology is almost there. we just need to start seeing some of it being picked up and actually used for things that people find useful. And from there, it'll just be building these network effects. Like when I want to create an application, I'm not going to create a login anymore. I'm just going to create a method to accept this credential. Yeah, so there's some more stuff like SSI meetup's really good, like good presentations, kind of webinars. You can just watch them. The Sovereign white paper is worth a read. You can have a look at Hyperledger Indy. That's kind of a lot of code. It's like the code base that powers Sovereign. You know, if you're really interested, you can get involved, start programming. It's just an open source project. Yeah, and then if you are interested in like the hardcore cryptography, there is some papers you could read. That's up to you. So yeah, I think that's me. If anyone has any questions.
So, in this sort of scenario, how do you get around the problem that like Bitcoin is sort of historically has had with the ledger being so enormous that it becomes impossible for single users to control or have a copy of that centralized ledger?
So I know Sovereign's way quite well. Obviously, the ledger's not going to get that big because all we're storing is we're not storing very much information, right? We're just storing these identifiers, which are pretty small. And Sovereign has it, so Sovereign is a distributed ledger, decentralized-ish, but they have stewards. So like you have to apply to become a steward to the Sovereign Foundation, and they try to make sure that their stewards are distributed across the globe, distributed across the technology stack, distributed across the organizations that they work for. They try to pick them based on having as big a spread, so it's as resilient as possible. And then hopefully anyone can run a Sovereign node, but hopefully you kind of trust this spread well enough to trust the kind of global good. Yeah.